Let's look at another word problem where we really have three options that we're choosing from in calculus. So one is there's no change. It doesn't ask anything about change. We're going to plug in to the original. Our second option is if it says average change. We have our formula for slope, f of b minus f of a over b minus a. There's our slope formula. Instant change is even faster. We're going to take the derivative and plug in. So taking our derivative and plug in whatever x or t value or what we have. So we have a long word problem here, and we're going to keep calm. It's one of the three options. We have the percent of families that had 3 or more children between 1960 and 2000 is approximately given by this P of T, where T is measured in decades with T equals 1 corresponding to 1960. So we are getting out percent of families, which is at P, for each decade we plug in. T equals 1 corresponds to 1960. So we plug in decades, whatever decade we're in, and we get out the percent of families that have 3 or more children. All right. The first part says, what percent of families had 3 or more children in 1960 and then in 2000? So it doesn't say how fast was the percent of families changing between 1960 and 2000, or how fast on average were they changing between these 2 years. So we don't see any change words or anything like that. So we're just going to plug right into the original function. We want to figure out what's happening in 1960 and what's happening in 2000. What are the actual percentages, not how fast were they changing. So no change words means plug into the original. And it's nice because they tell us T equals 1 corresponds to 1960. So we're going to plug in P of 1, which will be that 35.7, and we're going to replace T with a 1 in parentheses to the 0.18. This is kind of nice because 1 to any power is always 1, so 35.7 divided by 1 is just going to say 35.7. It's not a rate of change, so it doesn't need 2 units. This is just 35.7% of families had 3 or more children. Kind of a long unit. About 36% almost of families had 3 or more kids in 1960. If we compare that to what was happening in 2000, we need to figure out what T value we plug in for 2000. They tell us T equals 1 is 1960. So what T value is 2000? So be careful on this. It's decades, not years. So we're going to count by tens. I'm going to put 1 finger up right now. I have 1 finger up because T equals 1 is 1960. And then I'm going to count on my fingers from there. So T equals 1, I have 1 finger up is 1960. 2 fingers is 1970. 3 fingers is 1980. 4 is 1990. 5 is 2000. And there is no shame in the counting on your hands game with this. Better than getting it wrong and saying 6 or something like that. P of 5. We're going to do 35.7. And then in parentheses, we're going to replace T with a 5 to the 0.18. So grabbing your calculator, you want to see what percent of families you get. And we'll just round to maybe the second decimal place. So there's about 26.72% of families with 3 or more kids. Do those answers make sense? I would double check that before moving on. Of course, if we got an answer over 100, that can't be right. More than 100%. Also, our answers seem reasonable. There were about 36% of families with 3 or more kids in 1960 compared to about 27% in 2000. That makes sense to me because the cost of living is going up. There's more women going out and getting careers and maybe not staying home and being able to raise these kids. I'm one of 5, but not everybody wants to have this huge family. So it makes sense to me, these percentages, and then also that it's going down between those 2 decades of 1960 and 2000 because life is getting more expensive. The next part says, what was the average rate of change? Keying in right there are three options: average rate of change, slope. And the percent of families having 3 or more children between 1960 and 2000. We are going to use our slope formula. We want to plug in these t values. T equals 1 is given. We already counted our fingers and we said this is t equals 5. So we're going to do p of 5 minus p of 1 over 5 minus 1. The nice part is we don't need to do some extra side work. We already found P of 5 above. P of 5 was 26.72. I'm looking right here at my work in part A. Minus P of 1. We also found that in part A is 35.7 over 5 minus 1 is 4. So we already found those two y values, which is great. Set us up in the next part. Now I can just grab my calculator and do 26.72 minus 35.7 and enter that in. You get negative 8.98. It went down by almost 9% over 4 decades. So when we divide that by 4, we get negative 2.245% per decade. So let's interpret what that means. We got a negative answer. Is that okay to have a negative answer? You're having a negative percent of families that have 3 or more kids? No, that's not what that means. Remember, there's 2 units on it. It's a rate of change. So our slope is negative, which tells us on average the percent of families with 3 or more kids was doing what? Increasing or decreasing if we got a negative slope? Was decreasing by 2.245. Remember, if you say decreasing, you don't write decreasing by a negative. 2 negatives would cancel out and make it a positive. So we're going to say just decreasing by 2.245% per decade, at least between these 2 decades. So between 1960 and 2000. It may not have always been increasing. There may have been a time like between 1940 and 1960 where it was on the rise. There were more families having 3 or more kids. But between the 2 years we looked at, the average rate of change indicated a decrease. So on average, the percent of families with 3 or more kids was decreasing by 2.245% per decade between 1960 and 2000. Which makes sense. I would know that I got part B wrong if I got a positive answer, right? Because we said it went from 36% to 27% between 1960 and 2000. So going down from 36 to 27, we should have a negative average rate of change. Shouldn't be positive. All right, this last part says, how fast was the percent of families that had 3 or more children changing in 1960 and in 2000? How fast was the percentage families that had 3 or more children changing? So I'm seeing multiple change words here. I'm either going to have to use the slope or the derivative. It wouldn't be just plugging into the original because we're asked about change. Is it change at an instant or a change on average between 2 years? Well, it doesn't say on average. It just asks about the change in 1960 compared to the change in 2000. So really, if we don't see the word average, we're not going to use that slope formula again. We're going to use the derivative when we are asked about change and it's not average change. So I need to take the derivative of that function from above. So that function was 35.7 over t to the 0.18. So let's copy that down here. 35.7 divided by t raised to the 0.18 power. I need to take the derivative of this, but I don't want to have to use a quotient rule because I don't have t's in both the top and the bottom. So I'm going to take a second and do some algebra. If it's in the denominator, it must be a negative exponent. This is the same exact thing as 35.7 t to the negative 0.18. So now that I have a power there, I'm ready to take the derivative. So I'm going to call it p prime of t. I'm going to bring down my power and subtract 1 for the new power. The power is a decimal, which means I might need to grab my calculator quick and do 35.7 times negative 0.18. So we get a negative 6.426 t, and then I need to do negative 0.18 minus 1, which is going to give me a negative 1.18. There's my derivative. That will tell me how fast the percent of families are changing per decade. And I'm asked about 2 specific decades. It says what's going on in 1960 with that instant change and what's going on in 2000. So plugging in those 2 t values again, but now to this derivative. So I'm going to do p prime of 1 is negative 6.426, and then I'm going to replace that t with a 1 in parentheses, which is going to be not very exciting. 1 to any power is always 1, so we're doing negative 6.426 times 1, really, which is going to give us negative 6.426% of families with 3 or more kids per decade. Compared to 2000, I'm going to do p prime of 5 and do negative 6.426. And I'm going to replace that t with a 5 in parentheses. And we get negative 0.962. It's a rate of change. It needs both units. Percent of families with 3 or more kids per decade. So if we had to interpret this, in 1960, the percents of families with 3 or more kids is doing what? That derivative, that slope at an instant is negative, was decreasing by 6.426% per decade. Whereas in 2000, the percent of families, it's a long unit, with 3 or more kids is decreasing or was decreasing by 0.962% per decade. Those answers make sense. They agree with that, the amount of families having 3 or more kids is going down. It makes sense that it's decreasing more sharply in 1960 just because there was a higher percent to start with. So they started with 37% or 36%, and it was decreasing by 6%. By 2000, there's already only 26.72% of families having 3 or more kids, so they can't drop that percent by like 30% because they're only at 27. So they're at 27% of families have 3 or more kids, and that's dropping by about 1% per decade at that point. So just a good example with some long units of how to find and interpret in the original function the slope or average rate of change between 2 decades in this circumstance, and then plugging in for instantaneous change into the derivative.